So, we've all seen the headlines, right? AI mastering these incredibly complex games like Go or StarCraft, just crushing the best human players. But does that actually make it intelligent? Like, really intelligent? Today, we are going to dive into a pretty fascinating idea that says maybe we've been measuring intelligence all wrong, and we'll look at a whole new way to test if a machine can actually think the way we do.
Okay, so let's just jump right in with this comparison, because it really says it all. On one side, you've got an AI learning Go. To get good, it takes millions, sometimes billions of practice runs, all to get really, really good at one single game with fixed rules. Now on the other side, that's us. You sit down with a friend to learn a new board game. They explain it for maybe 5 minutes, you play a couple of clumsy rounds, and boom, you've got it. That enormous difference in how fast we learn, that's the whole puzzle we're trying to solve today.
So this brings us to the big question. Is being the best Go player in the world the same thing as being intelligent? Or is it just a really, really specific skill? The research we're digging into today argues that what we're seeing is more like hyper-specialization. It's like the AI has crammed for one single test its entire life. It can ace that test for sure, but give it a brand new one, it has no idea where to even start.
And man, this quote from the paper just nails it. Extensive optimization within fixed environments. You know, think of it this way. The AI has trained in the exact same gym with the exact same equipment for 10,000 hours. It's the strongest person in that one room, no question. But human intelligence, that's about being able to walk into any gym, anywhere, see a bunch of weird new machines, and pretty quickly figure out how they work. That's adaptation, and that's a whole different ballgame.
So what's our trick? How are we so good at this? Well, the secret sauce is something scientists call a world model. It is, basically, our brain's superpower. It's what lets us make sense of new things so quickly without having to learn everything from absolute scratch every single time. We build this little map of how we think the world works, and we just keep updating it.
So let's break that down. A world model isn't just a list of facts you've memorized. It's more like a little simulation engine running inside your head. It understands cause and effect, the rules, the physics of a situation. So when you see a cup sitting right on the edge of a table, your world model instantly runs a little simulation of what happens if it gets bumped. You don't need to have seen that specific cup on that specific table fall before. You just know. That right there, that's your world model doing its thing.
And here's the really cool part, how we build them. We start small, with specific rules. You could call it an instance model. You learn, okay, in the game Super Mario, mushrooms make me bigger. Got it. But then your brain does something incredible. It starts to generalize. It builds an abstract model. You start to notice, hey, in a lot of these kinds of games, jumping on bad guys is usually how you beat them. That abstract rule becomes a tool in your mental toolkit, and it's what lets you pick up the next new game so much faster.
Okay, so that brings us to the big idea from this research. If we want to build an AI that can learn like us, we need to test it like us. We need a totally new kind of playground, and they call this new test novel games. Games that are designed from the ground up, not just to see how well an AI plays, but to see how well it learns.
So what exactly makes a game novel? Well, the most important thing is that the rules are a secret. The AI gets dropped into this world with no instruction manual, no tutorial. It has to figure out the very laws of this little universe, what the goal is, how things work, just by poking around and trying things out. Just like a little kid learning about gravity for the first time, by dropping stuff.
Just try to put yourself in the AI's shoes for a second. You see this grid, you figure out you can move the little colored squares around. That's it. That's all you know. So, what are you supposed to do? What's the point? There's no score, no you win screen. You just have to experiment, come up with little theories, and test them until you figure out the hidden logic. In this case, you're trying to make the main grid look like the example grid. And here's another great example. The AI can place different blocks in this little world, and through pure trial and error, it has to become a little scientist and discover a fundamental law of this universe. When you add a gray block, the balloon goes down. See, this isn't about winning a game. It's about pure discovery. It's a test to see if the AI can build a world model from nothing.
But look, you can't just throw any weird, random game at an AI and call it a day. To be a really good test, these novel games have to follow a very specific set of rules, or as the researchers call them, desiderata. Basically, these are the rules for making good rules.
So what makes a good test? Well, first off, the rules have to be hidden. That's non-negotiable, because it forces the AI to explore. Second, the games have to be intuitive enough for a person to play. That way, we have a human baseline to compare the AI against. You also want to test different kinds of thinking. Some games might be about physics, others about social rules. And finally, a good test suite should allow for different ways of learning. Sometimes it's pure trial and error, other times you might get a little hint in plain text.
Okay, so why does any of this actually matter? I mean, who cares if we can build a better game-playing bot? Well, this is about so much more than games. This whole approach is about making a fundamental shift in how we try to build artificial general intelligence, AGI. It's about creating AIs that can actually function alongside us in our messy, complex, and totally unpredictable world.
And this table just lays out the shift in thinking perfectly. The old way was all about one goal: superhuman performance. The measure was how well you could optimize for one single fixed environment, usually by training on insane amounts of data. But this new way, the goal is totally different. It's rapid adaptation. We're not measuring how well you play, we're measuring how quickly you figure out the rules based on just a little bit of interaction. It's a huge shift from testing memory to testing true understanding.
And that, right there, is the real prize. The end game isn't an AI that can beat us at chess. It's an AI that can join your team at work and quickly figure out the workflow. An AI that can pick up a new piece of software without needing a 200-page manual. An AI that can collaborate with people it's never met before. Being able to build these world models on the fly, that's what separates a narrow, brittle tool from something that's truly generally intelligent.
For decades, we've focused on teaching machines how to master the games we've created. But this new approach is all about teaching them how to learn the way we do. And that leaves us with this one final, kind of mind-bending question. If we actually succeed and we create an AI that can learn and adapt with all the curiosity of a human, what do you think it's going to want to learn first?